This is Math Analysis, Chapter 10, Section 1, Analytic Geometry. I'm your host, Dr. D. Okay, now, as I've been telling you for several months, Chapter 10 is definitely the juiciest chapter in the entire year. This is the chapter that you guys really have to keep up with stuff. Now, surprisingly, Section 1 and Section 2 are going to be embarrassingly easy. You're going to be thinking, how in the world is this Chapter 10 so tough, like he's been saying? Well, Section 1, Section 2, you just got to make sure you learn that stuff. But Section 3, 4, 5, 6, that's like a jet plane taking off at a really steep angle. So you got to definitely stay up with it. The way I would give you the analogy, if we're out in the woods and we're collecting logs for firewood, and I'm going to be handing you logs and you're going to carry them back to the campsite. Now, if you put your arms out and I lay the logs right across and they're well organized and you can carry lots of logs that way. But if on the other hand you're sloppy with the way you take the logs, so the first log you kind of tuck under one arm, and second log you tuck under the other one, third log, okay, it's kind of balanced in between, fourth log, all of a sudden you're dropping logs. So, dropping logs? All right, you don't want to be dropping logs here. So, the key thing is, make sure you get each section as we go and stay on top of things. And then at the end of the chapter, you'll be saying, this chapter wasn't that hard. So, let's get going. Analytic geometry is basically looking at graphs and determining distances and midpoints. So let's just take a couple of points on a graph. So we'll take point A, that's x sub 1, y sub 1. And point B, that's x sub 2, y sub 2. And I want to know the distance from point A to point B. Okay, pretty simple. All we do is we turn this into a triangle. Now, the base leg of this triangle is the difference between the x's. It's the horizontal distance. So this is just x sub 2 minus x sub 1. The altitude of this triangle is the difference in the y's. Y sub 2 minus y sub 1. Now, the distance we're interested in is the hypotenuse of the right triangle, because fortunately horizontal and vertical are perpendicular. So, okay, that means the distance is going to equal the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's it, game over. So any 2 points I want, I can get the distance by just getting the horizontal distance, squaring it, get the vertical distance, squaring it, add those two up, take square root of the whole thing, and that's my total distance between the 2 points. Algebra 1. Okay, the other thing that we want to do is we want to look at the midpoint between 2 points. So, if I want the midpoint, which we'll make right here, M. Well, notice M is going to be the midpoint of the x's and the midpoint of the y's. So my midpoint formula is just going to be the average of the x's. What's the average of the x's? Add your x's up, divide by 2. So x of 1 plus x of 2 over 2. Then the average of the y's. So we add our y's up. Y's of 1 plus y's of 2 divided by 2. That's my midpoint. That's basically it. There's only one more thing, and that's going to be doing some proofs using analytic geometry. But just in case you didn't get this, let's try an example. So we want the distance between 2 points. I'll just make up some points. All right, so we've got -6, -2. And we've got, let's go with 8, 3. Find the distance between those 2 points. Okay, so distance equals the square root of 8 minus -6 squared plus 3 minus -2 squared, which equals the square root of 14 squared, which is 196, plus 5 squared, which is 25. So that distance is going to be the square root of 221. Square root of 221. And if we want a decimal approximation of that, we end up with 14.866. Now, it's a simple matter of just examining this distance and realizing that 14.87, or almost 15, is realistic. Now, the way I showed you to get this in the first place, not rocket science. The distance from from -6 up to 8 is going to be 6 plus 8 is 14. The distance from -2 up to 3 is going to be 5. So there's your 14 squared plus 5 squared, take the square root of the whole thing, and you get 221. So, that's it. Okay, now, let's say we want the midpoint of this segment. So where's the midpoint here? Well, the midpoint is going to be the middle of the x's. So what we're going to do is go, midpoint is going to be 8 plus negative 6 over 2, and 3 plus negative 2 over 2. So that ends up being 1 1/2. So 1 1/2 is the midpoint of this entire thing, because 1 is halfway along the horizontal line, and because you basically have 6 plus 1 is 7, that's half of 14, and then 1/2 would be the midpoint of the vertical line, which is half of 5 is 2 1/2, so 2 1/2 down from 8, or 2 1/2 up from negative, or yeah, 2 1/2 down from 3, or 2 1/2 up from negative 2. That's it. Okay, now like I said, the last thing would be we want to prove some things about geometric shapes. So let's actually get rid of our graph, because we're not going to be using actual numbers. We're going to be talking about theoretical. I hate when that happens. Let's, I don't want to get rid of that. Okay. All right. Prove that the median of a trapezoid is, let's see, maybe we want to say the length of the median. Yeah, okay. Prove that the median of the trapezoid is the average of the two bases. Okay, that's it. We're going to prove that the median of a trapezoid is the average of the two bases. So what we need is a trapezoid, and we need a general trapezoid. Now, this is where analytic geometry comes in. We're going to put it on an XY coordinate system. So here's our X, here's our Y. Now, we make a trapezoid. Now this is any trapezoid, this is not any special trapezoid. So we're just going to make, that's supposed to be blue, how embarrassing. There's our trapezoid. Now, we'll call it A, B, C, D. A, B, C, and D. Now notice this is a generic trapezoid, could be true of any trapezoid. Now, next, we're going to draw the median here across here. And we're going to call this E and F. Oh, you forgot what the median of a trapezoid is? Okay, the median of a trapezoid is the segment that goes from the midpoint of one side to the midpoint of the other, parallel to the two bases. All right, so we're going to name A 0, 0. It's always handy to have one of the points 0, 0. Now, it's not, there's no set way of making this. Like, we could have made D 0, 0. But if we made D 0, 0, then A would have been negative coordinates. So I'd rather make A 0, 0 so everything's positive. Now, then D is going to be some distance along the x-axis. So we'll make this 0, A, because it's A across here. Now, actually, before we, let's not name that A yet. Let's go up here, and we're going to call this some A distance and some B distance. So this is going to be A, B. Now, this is going to be, okay, the C is going to have to be, you know what, I'm going to make this a little bit steeper. Or a little less steep, I mean. Oh, come on. Okay. All right, so the B point is going to be some A distance this way and some B distance this way. So the C point, we know, has to be some C distance this way, and it's B up. Now the D point here is going to be some D distance this way, but it's 0 up. Okay, now, since EF is the median, then E is the midpoint of AB. So what are the coordinates of E going to be? Well, it has to be the midpoint, so that means it's got to be the average of AB and 0, 0. So the average of A and 0 is A plus 0 divided by 2, or A over 2. And the average between B and 0 is B plus 0 divided by 2. Okay, now, same thing here. I need the midpoint between C and D, so that's got to be the average between C and D. So that's C plus D divided by 2. And then the average between B and 0 is going to be B plus 0 divided by 2. All right. Now, what we're trying to prove is that EF equals BC plus AD divided by 2. The average of the two bases. Okay, so now I need BC. So BC, the distance from B to C, is going to be, it's just C minus A. So you could go the square root of c minus a squared, but it's just going to be c minus a. And AD is going to be d minus 0. So that means BC plus AD over 2 is going to equal C minus A plus D divided by 2. Okay, now what we have to do is prove that EF equals C minus A plus D divided by 2. Okay, so let's do that then. So the distance from E to F is going to be okay, notice we're at the same level across here, so all we do is say it's C plus D over 2 minus A over 2. So C plus D over 2 minus A over 2. Which equals C minus A plus D over 2. Therefore, EF equals BC plus AD divided by 2. QED. That's it. Game over. Have fun with these.